Let's take a look at this slide as kind of a review or a summary of the three processes of filtration, reabsorption, and secretion. One thing you can think about the kidney as being is just a gatekeeper, right? It's deciding what stays in the body by keeping it in the bloodstream. What do we need to get out of the body by moving it into the tubules and letting it go out as urine? So you've got kind of a barrier here, right? And things are going to stay in the blood over here or leave over here. But we do it in a three-step process, all right? So step one, filtration. So we're going to take things from the glomerulus. Remember, that's that capillary. We're going to filter them out into Bowman's capsule and then let it go into the tubules. Now, what doesn't get filtered stays in, right? We're going to leave it over here. So white blood cells stay in your bloodstream, red blood cells stay in the bloodstream, platelets stay in your bloodstream, proteins stay in your bloodstream. So basically, small molecules get filtered out of your blood. Those would be water, ions, glucose, amino acids, and wastes. All right, which would be great, but here's a problem. We don't want to lose all this water. We don't want to lose all our electrolytes or ions. We don't want to lose glucose and amino acids. We do want to lose the waste. So we leave that in the tubule. We're going to reabsorb most of this. So we reabsorb that and put it back into the bloodstream. So now we put it back over here. Then if there's anything over here that we might have missed, we can secrete and put it into the tubule. So that's going to be hydrogen ions to prevent acidosis, potassium if there's too much potassium, and if there's any waste that we didn't quite get when we filtered, we can secrete. So after these three steps, what you're left with is keeping this in your blood and getting rid of this, getting rid of wastes, hydrogen ions, so your urine ends up being a little acidic because of that, excess potassium, wastes. All right, so that's kind of your basic idea. All right, we're moving things, and then at the end of it all, hopefully we've kept what we need to keep in the blood, and we've gotten rid of what needed to leave the blood. All right, so summary of your nephron function. Rest of the PowerPoint goes over some tables, and I know tables aren't great to study, but it gives you kind of an understanding of what's in urine, what shouldn't be in urine. So this figure, or this graph, or table, sorry, tells you what gets filtered, what gets brought back in, and then as a result, what's in urine. So 180 liters of fluid gets filtered a day. That's a lot. Now, you don't urinate all that out. You bring 99% of it back in. So 99% of this number ends up being about 1 to 2 liters of urine a day. All right, so you filtered a bunch of water, but you've also reabsorbed 99% of it. So only about 1% of the fluid volume that got filtered ends up becoming urine. So 1 to 2 liters of urine a day is about a normal volume of urine. Notice protein. Protein gets filtered, but you want to reabsorb some of that. So you really shouldn't have very much protein in urine. You're going to have a little bit of sodium. You're going to have a little bit of chloride. A little bit of bicarbonate. Bicarbonate's a small molecule. It's the most important buffer we have in the bloodstream, so you better not lose it. So we reabsorb most of it. But there's a little buffer in your urine, which is good because if you didn't have a buffer in your urine, it'd be highly acidic. Notice glucose. This is an interesting one, and you want to make sure you understand this. It's a small molecule. You filter a lot of it out of the blood. But notice how much you reabsorb. All of it. So if you reabsorb all of it, you shouldn't have any in urine. 0. All right? Urea is a waste. You got a lot of that in your blood, or in your urine, sorry. Potassium's variable. Kind of depends on if you have high potassium or not in your diet. Uric acid is a waste. creatinine, not creatine, creatinine is a waste. So it's going to be in urine. So if you look at this column, these are some of the things you find in urine. Hormones. This is the biggest issue when it comes to the urinary system. There's too much information here, so let's not get crazy. But a lot of these hormones we've learned before. We're just kind of putting them in one table as far as what do they do to reabsorption or secretion. So let's try to simplify it. Angiotensin 2 is produced when you have low blood pressure. So what does it do? Well, what it's going to help do is keep blood volume up. All right, so we're going to increase the reabsorption of sodium, so we keep more sodium in the body. We're going to keep water in the body, and that's going to help increase blood volume. It also is a vasoconstrictor, so it's going to decrease filtration. All right, so angiotensin 2, produced when you have low blood pressure, it's going to do things to help raise blood pressure, which basically is decrease the amount of urine that gets produced by increasing the amount of sodium and water that stays in the body. Aldosterone, we've talked about it before, right? It's also part of that same system. These two work together. And aldosterone is going to secrete potassium but reabsorb salt and water. ADH just reabsorbs water when you're dehydrated. AMP does the opposite of all three of these. So if you think of all three of these together, they're retaining salt and water and increasing blood pressure. AMP does the opposite. Gets rid of sodium, gets rid of water, and that way it helps decrease blood pressure, whereas these help to increase blood pressure. And then parathyroid hormone, remember that's all about calcium, increases reabsorption of calcium at the distal convoluted tubule. So that's a summary of your hormones. Normal urine, this is kind of a table describing what normal urine is, some of the characteristics. There's the volume, 1 to 2 liters a day. Color, we've all seen it, anywhere from a light clear yellow to a darker yellow to almost an amber color. Keep in mind that could indicate your concentration difference, right? Dilute versus concentrated. It could also be influenced by other things. So color of urine isn't always just because of the concentration. It could be darker in color if there's blood in the urine. It could be a different color if you have something in your diet that has a pigment, like beets. All right, beets are bright red because they have a pigment in them. If you consume a lot of beets, your urine is going to look bloody because of the red pigment. So color typically has to do with the concentration of the urine. But again, there's things in your diet. There's even medications that might affect the color of urine. Turbidity is cloudiness. It shouldn't be cloudy when it's freshly voided, when you first urinate it. It will become cloudy if it's sitting around, but it shouldn't be cloudy. Odor, we've probably all smelled urine. It can kind of become more ammonia-like if you don't flush the toilet. Because bacteria will convert, and form ammonia in the urine. There's things that affect the odor of urine. One classic one is asparagus. There's a molecule in asparagus that if you metabolize it a certain way, it gives off a characteristic odor. What's interesting is there's a genetic component there. So some people can eat asparagus and their urine doesn't stink, whereas other people can eat asparagus and their urine does stink. And then sometimes if it's from a diabetic, the presence of glucose and ketones can give off a little bit of a fruity odor. pH. So pH of urine has a big range, 4.6 to 8. Average is about 6. Diet can affect that. High protein diets can increase the acidity. Vegetarian diets can make the pH go up, increase the alkalinity. And then specific gravity is a better measure of concentration. So notice you can't really rely on color to tell you how concentrated urine is, because color is very subjective. So it's better to have an objective measure for concentration, and that's called specific gravity. Basically, it compares the urine to water. Water, they give a density of just 1. And if urine is more dense, meaning there's more things in it, the number is going to be greater than 1. So a normal range for specific gravity is 1.001 to 1.035. Anything above this number means you're getting more concentrated. Maybe you're dehydrated. And it can't really get below this number, right? You can't urinate out water. That's impossible. All right, so there are some characteristics of normal urine. Last slide is just some abnormal things that might be found in urine. Albumin should not be found in urine. All right, that's a protein that shouldn't get filtered. So it is too large to pass through the capillary fenestrations. If it does get found in urine, there's a problem. All right, it could be the filtration membrane is injured or diseased because it's letting that protein out. It could be from high blood pressure, forcing the protein out. Could be irritation of the kidney cells, maybe a toxin or heavy metal poisoning. But I want you to know, A, albumin should not be in urine. B, why? And the answer is it's too big. It should have never gotten filtered out of the blood in the first place. Glucose shouldn't be in urine, but for a different reason. Glucose does get filtered, but it should get completely reabsorbed. So glucose should not be in urine. It could be found if you're a diabetic, some severe stress, high epinephrine can cause it. But again, I want you to know glucose shouldn't be in urine, and the reason is it gets completely reabsorbed back into the blood. And then obviously red blood cells shouldn't be in urine. If it is in urine, we need to look for the reason. Could be inflammation of, say, the kidney. It could be irritation from kidney stones. Could be a tumor or trauma. Or it might just be a contaminant. It might just be a contamination from menstrual blood from females. And then finally, ketones. Ketones, what are they? Ketones are when your cells are burning too much fatty acid for energy. So your cells like a certain amount of glucose, fatty acids, and maybe an occasional amino acid for energy. If you take away the carbohydrates, either by not being able to get them into the cells, such as diabetes. Remember, in diabetes, glucose is having trouble entering cells, either because of the lack of insulin or the resistance that the cells have. So the cells aren't getting glucose, and instead of burning glucose, they burn fatty acids and produce ketones. And ketones can cause acidosis of the blood, and they can be found in urine. Another cause might be anorexia or starvation or extremely low carbohydrate diets. In all of these situations, cells are not getting enough glucose for energy, and they will burn fat and produce ketones. All right? So that's the abnormal things that might be found in urine. And there's other things that might be found in urine, but this is some of the more common things that we look for that could potentially indicate problems with either the kidney or other medical conditions. All right, so that's the end of the urinary system. Good luck. Let me know if there's any questions. Um, get to work. Thank you.